Alright, we're practically done with rigging our character. So it's time to start testing it and also addressing some of the last issues we'll have with the rig. And then you're going to see what that's going to be in a second. So this is our finished rig with all the meshes displayed and all the controls relevant to different parts of the character. So what we want to do now is let's do a little test and move them around and see once we get them into an actual scene what this is going to look like. So I'm going to grab the main control for the character and just move it to the right like so. And you will see that there's something odd happening here. Some of the meshes are moving away from the rig. And what is this that is going on? Well, what you see here is something that you will encounter rather often when rigging characters or assets that are deformed. What you see here is what's called double transform. So if you take a look, you will notice that most of the meshes on the character have moved in the same direction you were moving the rig, but twice as much. So that's why this is called a double transform. They are being transformed. In this case, this is a translation transform, but it could be a rotation, it could be scaling, as you will see in a second, twice as much. And the reason for this is because there are two things in the scene affecting how these meshes are being transformed. They are being transformed first by the hierarchy itself. As you know, one of the things that happens with hierarchies is that the children will always inherit the transformations of their parents, which means that I move this item, which is the topmost item on the hierarchy, all the children in it, which is the entire rig, move with it, so our mesh is coming along for the ride. And the second transform is by the items deforming the mesh, which are the joints in this case. So these joints are also inheriting transforms coming down from the hierarchy. So this mesh is being transformed twice, one by the hierarchy and a second time by its deformers. So that's why you get this double transformation effect. Now, why don't we see that in this other mesh right here, in these other meshes in the scene? Well, the reason is it's because these guys, as you can see, they're part of the cut res of the character. They're the meshes in the cut res group. These guys are not being deformed. They're static meshes. They have no deformations whatsoever. They're only parented in the hierarchy, and that's all. So they are behaving just fine. But the other meshes are being double transformed. And in some cases, you can see these guys are way over here. We're going to see what's going on with that in a second. So the first thing we need to do is, well, let's hide the cut res for now. Let's not get distracted. And let's just focus on the meshes themselves. So all these items, we need to stop these double transforms from happening. And that's actually quite easy. If I select one of these meshes and I go to their channels, you will see that in the channels list we have our mesh channels, and we have these three channels called inherit position, inherit rotation, and inherit scale. These channels control whether the mesh is going to inherit, or actually any item, because this applies to any item in Modo, if it's going to inherit transforms from its parents. So as you can see, the channels are set to true. So what I want to do is to set these to false. I will have to do that for every mesh on the character, which is a little bit of too much work. So what I'm going to do instead is I'm going to set these properties on the high-res folder, okay, on the high-res group locator, and then all of the meshes will behave correctly because they're not going to be inheriting the transforms from their parents. They're going to be stopped right there at the group locator. So let's see what happens. If I take this group locator and I turn off inherit position, rotation, and scale, you will see that the meshes immediately go back to their correct locations, with the exception of the belt. We're gonna check that out later on. But that's pretty much it. That's how you solve this problem. So it's very easy, because all you had to do is stop the inheritances right here at the parent for all the meshes, and then all of them, well, they're not receiving them anymore. The only thing you have to be careful about is if your character has a mixture of deforming meshes with non-deforming meshes, to not prevent the inheritances from reaching the non-deforming ones, because then they're not going to move with the hierarchy, because they're not going to be transformed at all. They're just going to stay in space, which is what would happen if I turned them off for the cut res. So you don't want to do that. If that's the case, inside of the high res group locator, I would create two more groups, one called deforming meshes and one called rigid meshes or something like that. Place the correct meshes in the appropriate folder or group locator, and then just turn off inheritances for only the deforming meshes. So that's how you solve this problem. So that's it. We're done. As you can see, it's not a complex problem to solve. I just want you to be aware of this, because you're going to be encountering it quite often as you rig. Now let's take a look at another thing we have to solve with our character, which is related to how it scales. Let's try scaling it up. There's something odd happening. As you can see, a lot of the meshes are behaving correctly. The belt is definitely not, and our character's body is not either. Even worse, the face is completely ripped off from the character. So what's going on here? Well, this is actually a current limitation in the software, and I'm going to show you what it is. This is actually present in other softwares as well, but there's other ways of dealing with this. In Modo, we currently can't, so we have to fix this in a different way. I'm going to show you what's going on. If we go to our Deformers tab, where we have all of our deformers for the rig, let's go back to our normalizing folder ACE folder, where we have the body bind and the face, which is what we see here, both mixed together. If you remember, our body bind normalizing folder is set to use quaternion interpolation. Now, dual quaternion interpolation has this big problem, which is it doesn't like scaling at all, which is what we see here. That's why this is not working. Moreover, the face normalizing folder is using local interpolation, which means that every influence in here is determining how it's going to work. So we have both methods mixed, and that's what's giving us this crazy problem right here. If I change my interpolation to linear for the body, you will see that now our mesh is scaling properly. Okay, so that's what we need to do to fix this. This, as I said, is a current limitation on how dual quaternion interpolation is implemented. Ideally, the dual quaternion interpolation should not be a folder level setting. It should be actually a weight map, where you could paint on the mesh which areas are going to use dual quaternion interpolation and which ones are not. Those not using it would use linear interpolation, and that way you could be able to set exactly where you need which type of deformation on the mesh. But for now it's like this, so the safest thing to do is just to set everything back to linear. And I want you to be aware of this, because this might change how certain areas of your model deform, so you might have to adjust your weighting accordingly. But for now, this is what we need to do if you intend to scale your assets, which in most cases you will need to. So we set this back to linear, and now our friend is going to correctly scale up and down. As you can see, oops, I lost my scale gizmo right there. Okay. So we have no more of that problem. Okay. As I said, we're going to check out the belt in a second. The other thing I want to solve, since we're at it, is as you can see, as I scale up and down the character, these items are not resizing. They're becoming really big, and that means that the rig is going to be hard to use at either bigger or smaller scales. So let's fix that out. And I'm going to show you how we fix this, and it's actually also quite simple. What I'm going to do is I'm going to create a new schematic workspace, and we're going to call this one Ace Scaling. Okay? And we're going to bring in our scaling control. And we're going to bring in the Y channel. Okay. And let's start, for example, with this guy right here. Okay. Which is one of the controls we're using to scale the character. Let's go find them actually. It's all these guys. Let's bring them in. Okay. There they are. They're coming in with their dynamic parents. So let's just hide those from the schematic. I'm just gonna do this very quickly, just because I don't need them. So let's start with, let's say, who is this guy? It's the one right there at the top. Let's move the others backwards. So why is it not scaling if it's part of the hierarchy and everything? Well, the reason is we set its display properties to something that doesn't change its size on screen. If I go to the locator shapes, you will see that we have the align to view checkbox enabled. So this makes the item stay constant in screen size. And the size of the object is this one right here, size X and Y. So let's bring these items to the schematic view. And what we're going to do is we're going to multiply the original size of the locator by the scale value we're getting from over here. Okay. So all we need to do is get a multiply node. So let's go to our math nodes, get a multiply node, and I'm going to, let's see, what's the size here? 82.7 millimeters. So that would be this value, I believe. Let's see if that's the case. Let's plug it directly to, we have to multiply by 1, otherwise it's going to disappear from the screen. There we go. So let's plug it into the size X, and if the value is correct, we should see no change, which is correct. So because otherwise if I enter 1, that's the equivalent of 1 meter. And now I take my size Y value. Let's plug this into Y2. So take the scale Y value from the control and plug it as the multiplier for this value. And as you can see, the item immediately changes size to be proportional sorry, with the scale of the character. All we need to do is connect that to the size X and Y channels of the other controls. So, and actually this is going to be good because it's going to allow us to unify the size of these controls. As you can see, some of them were not exactly the same size, and some of these are actually missing their wire colors. We can take care of that later. Let's just do the size connections. There you go. Let's see. Let's bring in this guy. size display. Here it is. And let's connect this guy over here. Perfect. And let's use this guy now. Again. And actually I'm gonna do it the other way around this time. I just have to, with both channels selected, hit Shift, grab one to gang both of them and connect them to the output of my other node. So we're almost done. And the last one, which is our friend over here. So that takes care of the scaling of our controls right here. And as you can see, I can now scale up or down my character. I should set the correct select action for this node to scaling. And they remain proportional. They stay proportional to the size of the character, which is great. Let's go back to our smaller size. And let's now do these other controls. So as you can see, these are the FK controls and some of the IK controls, the matching ones. And they have the same basic situation, which is not scaling due to their display sizes. So in this case, because they are circles, we need to use the radius channel, which is set to 55 millimeters. So let's add another multiply node, and let's bring this down. Again, scale Y over here, and because it's going to be 55 millimeters, is 0.055, and let's add the radius channel to our friend and just plug that into it, and as you can see, it gets resized properly. So that's all we have to do, basically. You can go on and keep doing the rest of the controls. And actually, one thing is that you will notice that some of these controls, depending on which part of the character they are located and their function, might have a different radius size. If you want to preserve those radius sizes, all you have to do is use different multiply nodes with different values to keep using those. Like, let's say, for example, this guy, well, this is 252 also. This guy is going to be smaller, I believe. 40. This one is 40 millimeters, which is a little bit smaller, so you can create another multiply node with 40 millimeters and just connect it accordingly. And that way you can keep your relative sizes. I guess you get the idea. You can size them to whatever you want, whatever feels comfortable. The thing here to consider is basically well, wiring them up to this global scale of the character. So that's pretty much it. I'm gonna leave it at this because I mean, you don't have to see me do the rest of the character. But in the next video, we're going to be looking at the other part of our character that is giving us problems, which is the belt right here. So I'll see you in the next video with all of this already finished. Okay.